In order to have the Pong game working, we need to have four main functions. We need to have a screen function, a player and point function, and a ball restart function. In the screen function, we need to have the button, the labels, the player 1 and 2, the ball, and keybind code. In the player function, we need to have the move and collision code. In the point function, we need to check the X values in order to see if there is a point scored, and then we need to change the labels. In the ball restart, we need to reset everything, the players, the ball coordinates, and the direction of the ball. Welcome back to my channel. Today I'm going to teach you guys how to code Pong in Python using tkinter as your GUI. As you can tell, is a lot of lines of code, so I'm going to be breaking this video up into maybe 2 or 3 parts, depending on how short I can make these. The first thing you want to do is import tkinter as tk. We're going to define our screen function. We're going to open up a new window, and we're going to main loop that window. And let's call on our function, and let's add in a little canvas into here. So we'll do canvas equals tk.canvas on the root with a width of 600 and a height of 400 for now. So let's, oh, we got a packet too. Don't forget about packing, man. Crazy stuff. So let's do this. Let's run our function, go to our desktop. There you go, there's our window. Next, we are going to create the players. So player 1, and we're going to put him on the canvas, and we're going to create a rectangle for tkinter to map out for us. So we're going to use these specific coordinates right here: 40, 165, 50, 235. We're going to fill it with black, and let's see what happens here. We're going to run this, and let's go to our finder. So right there, that's about the width and height that I want our player 1 to be. So now we just need to copy it over to the right side, and we'll be on to the next thing. Next, I want to add in the opposite rectangle, player 2. So let's do that right now. Let's do canvas. Let's create our rectangle again, and we're going to put it on these specific coordinates right here. So let's test this out. And there we go. On each side, we will have our player 1, player 2. Next, I want to add in the next player. So player 2. We're going to do the exact same thing as we did up here, except with some different coordinates. We're going to do these coordinates right here. And that'll create our second player, our second rectangle. And then next we want to create the ball, our little ball that we have to hit across the screen. Next, we are going to create the ball. So let's do ball equals canvas.create oval, my bad, with these coordinates, and fill equals black. Same as always. So let's test that out. We get the ball right in the middle. So next up, let's create the animate function. We're going to animate the ball through this. So we're going to need to get the velocity of the ball at any given moment. So first, we need to get the velocity of its x component, and then the velocity of its y component. Next, we need to find out where the ball is heading. So we will do a little trig. We will do 3 times math.sine of direction. So there's a lot going on here. First, we need to import math, and that'll take care of the math and the sine function. Next, we need to set direction equal to something. So in this case, will be 0.5. As you can see down here, I did 2 sine functions. I did the 0.5 and negative 0.5. Each of these goes out to roughly 0.5 again, but each of them gives us negative. And if we do cosine of 0.5, we get a positive, and if we do cosine of negative 0.5, we also get a positive. That's why I'm not using sine and cosine. It's because when I want to flip the ball after it hits one of the players, I want it to switch directions, and that's why cosine won't be helpful in this case. Next, I want to specify the velocity y, which will be the exact same thing for a little while, and then we'll switch which sign we are going to be multiplying by. So later on, we're going to do direction 2 for the x, because when we hit the player, we want to flip only the x value. We don't want to flip the y value. So we're going to take two different numbers, and we're going to use them in this function. Next, we're going to get the coordinates of the ball and move it accordingly. So we'll do canvas.chords of the ball. We need to go back up here and global ball. Then we need to move the ball and global canvas. Then we need to move the ball. So canvas.move ball, and then by velocity x, comma, velocity y. Then we need to call on the function multiple times. So canvas.after 1 millisecond, we need to animate it. We need to call the animate function, which is just our function in general. So it's going to get the velocity x, velocity y, the coordinates. It's going to move the ball, and then it's going to do this an infinite amount of times until we quit our screen. We also need to move this root.main loop after everything, because everything is dealing with the canvas, and we need to globalize it. So let's test this out right now, and let's see what happens. Absolutely nothing. All right, so let's do some debugging here. So I did say that we were going to call this canvas after every millisecond, but I did not say animate. So we never get to this line right here. Debugging at its finest, obviously, and we need to globalize direction. So combine those two things, we get a working thing. The ball's off the screen by the time I get there. It's too fast. So let's set up some conditionals with these x values and y values that we set equal to canvas chords earlier. Next, I want to create an outline for the game to be shown a little better. We want to have the points on the bottom, maybe a restart button. I want to add in a difficulty meter on the bottom as well. We want those buttons to be there, and just to make it a little cleaner game. So we need to create a rectangle, and I picked out some coordinates here, and let's test if this works right here. Let's go there, and there we go. We got our outline there. So now we can figure out this darn collision, because that's a real heckin' problem, man. Notice our coordinates right here for our outline. X, Y, X, Y. That's how it goes. So our top left coordinate will be 10, 10. Our bottom right coordinate will be 590, 390. So these are our two Y values that we're bounded by, 10 and 390. So let's set up some conditionals in our animate function. If the Y2, which is the bottom right coordinate of the ball, is greater than or equal to 390, or if Y1, which is the top left bounding coordinate of the ball, is less than or equal to 10, then we will do this right here. Next, we need to set up an additional conditional. Say that 10 times fast. We need to do if Y2 is greater than or equal to 390, which is just this part here, we'll flip the direction of the ball. We'll flip the times direction, and that'll flip the y, because we set the y to direction. If we were to set this and this to sign of direction, then it would also flip the x. So as we're going this way, let's say our ball is the cursor, it'll hit the top and it'll go right back to us, which is what we don't want. We want that x value to stay going to the right and the y value to flip. Next, we need to do a little bug prevention. So we're going to take the canvas chords, we're going to change the chords of the ball to be the same exact thing as before, y1, except -1. We're going to do -1. I'll explain that in a minute here. the way that the move function works is beyond me. I have no idea how to explain it. So that's why I have to have this right here. This little y1 minus 1. I'm pretty sure it's when it hits this thing, it still moves. And so it hits a conditional. It's like, oh, it is greater than or equal to 390. We're right here. Let's say this is the bounding box. Then we need to say, oh, yes, it's here. Oh, but it's also here. So we need to start moving backwards after we flip the direction. It just makes sure that it starts moving backwards because it could be greater than 390. It could be like 391.5. And then we are going to flip the direction. Then we're going to hit the top again. And it's just going to be a big problem. So that's why we need that right there. Next, we need to set up the last conditional in this function. We need to set up the else. So it'll go through here and be like, is it greater than 390 or less than 10? Oh, it is. So let's go into here. Is it greater than 390? No. Then it must be less than 10. So let's go into here, this else. So we need to do the exact same thing here. We need to flip the direction, but instead of moving it up by 1, which is minus 1, less than 10 is up here in our bounding box. Let's say this is our outline. We need to hit this, and we need to go down 1. So we need to add 1 to the y value in order to not mess up with this move function and all that, BS. In order to make sure that this works, let's go half screen. So let's play this, and look at that. It's working. It hits that and then goes off to infinity because we have no x conditional. And that's good. We don't want the x conditional because in the next video, we're going to set up the collision detection between the player 1, player 2, and the ball. So we're going to have to make sure that happens. And then we're going to add in a point system. That's going to be fun. So stay tuned for the next video. I hope you guys learned a lot this time. I know we only coded 42 lines, but we set up the basis, and now everything has to just get added in one by one, and we can do it. We can totally do it. Until next time, guys. See you later.